like another way to write it?
Don't you put the square root like the,
Yeah, okay, yeah, yes, you can do that. Here's what I'm looking for. I'm looking for 2 to the power of 3 is really 8.
oh, okay, yeah.
Have you seen that before?
Yes.
Okay, fantastic. Now, like I said here, let me send you this link, and if you want to, you can open. You don't have to. But it's an exponent reference sheet, and these are the ones that I think are worth knowing, kind of right on the edge of worth knowing. But it saves you a ton of time because usually you don't get your calculator in this part of the course here. So when you have an exponent to an exponent, as you have here, 2 to the third to the 1/3 power. Do you remember the rule when you have an exponent to an exponent?
You add them
Multiply.
or multiply. Yeah. That's when
Multiply.
you, yeah,
Multiply. So it's 3 times 1/3, and you actually may want to come off to the side and do that. What is 3 to the 1/3, or 3 times 1/3?
is 1.
It's 1, so it becomes 2 to the power of 1.
Yeah.
Okay. I'm having some real issues here with copying and pasting for whatever reason. All right, let's look at number 7. Number 7 is n equals 2, a equals 0. So it's writing 0 to the 1/2 power. And you're totally right. You were trying to tell me this previous problem. You're like, hey, isn't that the square root of 0 to the power of 1? And
Yeah.
yes, it is, but they don't necessarily want you to write it this way. Okay. But the square root of 0 is 0. And 0 to any power is 0.
Yeah.
So a lot of ways of saying that it's 0.
Yeah.
All right. Let's look at number 9 here. All right, so this one here gets a little bit more difficult. So again, you write the number -32, and really it's in parentheses. Now I didn't do that for the first couple, but it's really in parentheses, especially when it's negative, 1 over the power of 5. Okay. So I hope by this problem you're comfortable with where we're putting the numbers there and there. Now, did you get a chance to open that reference sheet that I sent you?
Yes.
Okay, can you find 32 on there and tell me how you might write 32 as a base to an exponent?
So it's under the second,
Yes, that's power of 2 to what number?
to the 5th.
5th, yeah. Now the way the negative works here is -2 to the power of 5. A negative to an odd exponent always gives you a negative. A negative to an even gives you a positive. So it's actually -2 to the 5th to the 1/5 power.
Yeah.
And what is 5 times 1/5? So that's your next step here. Multiply the exponents. So that becomes -2 to the power of 1, which is just -2.
Yeah.
And if you're thinking, oh, I'll have a calculator, you will not.
Yeah. No.
I'd be very surprised. I mean, that you'll see in the next grouping of questions, it says no calculator. All right. Can we move on to 11, or do you want a few more examples of those that we just did?
We can move on to 11.
Okay, so this is not written well. Let me rewrite it here. It's kind of an inline thing. So it's really 64 to the 1/6 power. Okay, and your goal here is to rewrite 64. Now, if you look at that reference sheet I sent you, there's 2 possibilities. It's either 8 squared. Actually, there's 3 possibilities: 4 cubed, or it's 2 to the power of 6. Okay, and I think it's a reasonable thing to ask, well, which one do I use? Well, the answer is they all work, but it's probably best to use the one that matches the fraction whenever possible. Okay, so I would rewrite 64 as 2 to the power of 6, and notice I'm putting it in parentheses, to the 1/6 power.
Why is it 2 to the power of 6?
So that means it's 2 times 2 times 2 times 2 times 2 times
Oh.
2.
Oh yeah, I see it now. Okay.
Yeah. And there's a couple that works. You got to just decide, okay, I think this is the one that will work best here.
Yeah.
All right. Move on to number. Oh, sorry. So we actually have to do this one. So 6 times 1/6, the exponents, because they match, it just becomes 2 to the power of 1, which is just 2.
Yeah.
They should work out nicely most of the time. Okay. 13 here. Actually, just be easy to write this. It's 25. Is that to the 3/2 power? Yeah, I think it is.
Yes, it is.
It is. Okay. So you're always looking at the base. You're always looking to figure out, how can I rewrite the base? Base, not the exponent. So the base is 25, and 25 is 5 squared. So 5 squared to the 3/2 power. And from here, you want to multiply the exponents. Can you do that for me?
Yes. So it'd be 3.
Yeah. So your answer now is 5 to the power of 3, which is correct, but it's probably not preferred, meaning there's more to do here.
Yeah.
So you have to remember, oh yeah, that's 5 times 5 times 5, or it's 125.
So that would just be the answer.
That's the answer. So sometimes you're done after you multiply the exponents. Sometimes you've got to do a bit more. So we'll look at 15 next. 15 next. All right. Okay, so this one I'll rewrite a little bit here. Minus 243 in parentheses to the 1/5 power. Okay. The best way to do this is to find 243 on your on the sheet there, and let me know what you see. What is it as a base to an exponent?
It's 3 to the power of 5.
Yeah, now that gets you the 243. The question is where does this negative come in? And this is my preference, is to put it in parentheses like that. Because like I mentioned before, a negative to an odd power always gets you back a negative.
Yeah. Okay.
Okay, now we have that to the 1/5 power, so you have to multiply the exponents.
So then it would be just 1.
Yes, it's minus 3 to the power of 1, and anything to the 1 power is itself, or just minus 3.
Yeah.
All right, so 17, kind of another little wrinkle. Just when you think you got it, there's something slightly different. So 17 is 8 to the power of negative 2/3. Can you tell me how to rewrite 8?
2 to the 3rd.
2 to the 3rd power. Yeah, and then you just multiply the exponents. Okay, so 3 times negative 2/3 is negative 2.
Yeah.
Okay, now that is, so this, here's the way you rewrite it, but this is not the answer. You have to remember the following. If you have a negative exponent, it becomes 1 over the same thing to a positive exponent. So in terms of like your problem here, it becomes 1 over 2 squared.
Right. And that's just your answer?
Well, you have to simplify. What is
Oh, yeah. So
2 squared?
1/4.
1/4, yeah. Okay. 19. These are horrible. Oh, boy. As a student, you don't know enough to be able to correct mistakes. It's just a bad question here.
Yeah.
All right. So I'll try to point you to the problem area and then see if you can. So the issue is from, it's really from here to here, this line to this line, but more specifically, it's going from this 27 1/3 to a 9.
Yeah.
And I guess I'll just let you think about that for a moment. It is wrong. It is not 9.
Yeah.
So what should the number be? You just try
So
to
it's one. So it's 27 to the 1/3 and then to the second after that.
Yeah, but don't even worry about that. So like
Okay.
here, I guess what I'd like you to do is reduce that. And I think you'll see right away what the problem is, but because you're gonna have to rewrite 27 as some number to some power.
It should be 3 to the 3rd.
Yeah, and then when you have the 1/3 on the outside, when you multiply those exponents, what do you get?
1.
1. So it's really 3 to the 1. And then now we can add in that 2 on the outside.
Yeah.
Okay, so the issue is that 27 to 1/3 power is 3, not 9. And somehow you have to convey that in words.
Yeah. Okay.
All right, let's keep going here. All right, so we got 21 through 24 following instructions. It says match the equivalent expression. Okay, and there's I think you just need a little bit of a nudge here in terms of like what to do. So let's just say it was oh, sorry, let me give you an example here. So let's say it's the square root of x squared to the power of 3. Okay, something like this. So this 3 on the outside can actually be multiplied by this number on the inside. Okay,
Yeah.
so this would be equivalent of the square root of x to the 6th. Okay.
Yeah.
Now that's one thing that may not actually help us here now that I look at these a little bit closer, but I thought that's the direction they were going. That's not the direction they're going. What they want you to do in 21, let me just focus on this, is they want you to rewrite this as 5 to the 1/3 power to the power of 4. And then they want you to, just like we've been doing, multiply the exponents.
Okay. So it would just be 4/3.
Yes. So you can see that goes to letter B.
Yeah.
All right. Let's keep going here. So 23 is kind of another little oddity, a little bit different, but it's 1 over 4th root of 5 to the power of 1. So if you just looked at the bottom, how would you rewrite the bottom as a number to an exponent? What would the exponent be?
It would be 4.
So see how this one up here went to the numerator and the 3 went to the denominator. That's the same thing here. This 1 has to go to the numerator, 4 goes to the denominator of the fraction. So it becomes 1/4 like that.
Oh, okay. So then it would
So-
be yeah.
So the only way now to move the exponent up is to make it negative.
Yeah. Why don't you make the 5 negative? Because you're moving the exponent up.
It's only the exponent that gets affected. Yeah, it's something you saw in a previous course. We may have to do some problems with that at some point, but
So wouldn't it be A?
Yes.
Okay.
All right. Do you have a calculator? Because now,
Yes,
after that sort of this, I said, hey, these aren't going to be calculator. Looks like you've got a couple that will be.
yeah, I do.
Now there's a couple options here. Some calculators actually allow you to put the root in. Some do not. So do you know if your calculator has like a 5th root or an nth root?
It doesn't have a button that says.
It'll be under math if you don't have it. And I can pull mine up, but it may not be exactly what you've got.
It says like, oh wait, yeah, I think it does.
So like, let me show you how I would work this problem out. There's a couple of options here. So if you go to math and you see, actually it says X, root X there.
Yeah, that's what I pressed.
Now, what you're supposed to do is actually put the X in first. So it's 5 and then the X root of that. So I don't like that because it gets confusing. The other thing you could do is use the exponent form that we've been talking about. So 32,768 to the power of, and you need 1 divided by 5. This is my preference for how to enter it. Whereas you have to do this X stuff, you got to remember where it is. It doesn't even put a parentheses, which is weird. It's kind of, it's possible to make mistakes. Now, some of the modern ones I think have like a little better interface than this one, but this is all I've got for it. Okay, so will you try number 27 for us and let me know what you come up with? Actually, this one you will have to round. It doesn't work out nicely for 27, so just keep that in mind.
Okay. So you just put in 25 and then
To the power of negative 1/3, all in parentheses.
oh wait, how do you do fractions in right?
Do you want me to share my calculator screen again for this one?
Yes, I don't think I've
Okay.
ever had to do fractions on this type of calculator.
Okay, so let me share that. It's my new share. Okay. All right, so this one is 25 caret and then parentheses. Just so I like, I know you can create a fraction in some of them, but I just go with parentheses so that the calculator knows to divide first and then do it to the power of. So just try entering that or something on your calculator that's similar. See if you get that number there.
Wait, how did you do the fraction again?
Just the slash, just division.
Oh.
Just division operator. Yeah.
Oh, okay.
And
yeah.
maybe yours does it nicely.
Oh, I think my negative was, I didn't put the negative. That's why I got the wrong answer. So 25 caret parentheses negative 1/3. Yeah, I got 0.34.
Okay. So round to 2 decimal places, 0.34. So let's look at number 29. So this one I would just enter in 20,736 caret. And then when it's a fraction, I know to enter it in parentheses 4 divided by 5, like that.
2008. Yeah.
Now the last one, you really need to rewrite slightly like we were doing in 21 through 24. It's better if you can write it as a fractional exponent.
Okay.
So 2840. Okay, just writing out the answers in case you want to look at them later. So it's 187, which is the base, to the power of, and this is the hardest part, is figuring out the power. It's 3/4.
Oh, yeah. So the number that's on the outside of the parentheses always goes on top.
Yes,
Okay.
yes. So like we were doing here, the fourth root of 187, this 3 really goes in here. So it's really the fourth root of 187 to the power of 3, which is 187 to the 3/4 power.
Yeah.
Okay, 33. Is 33 on the list?
Yes.
Okay. All right. So you haven't done volume since geometry, but it's a known formula. The volume of a sphere. Volume of a sphere is 4/3 pi r cubed. And they give you the volume. They tell you the volume is 216 equals 4/3 pi r cubed. Okay, so you're effectively just solving for r, okay, which is not difficult, but you have to remember the steps, right? You have to remember, okay, I got to undo the 4/3. I got to undo the pi. I got to undo the cube root, the 3, the cube. So there's a few steps here. I'm not sure how comfortable you are with any of this, but you're going to undo this by multiplying both sides by 3/4.
Okay.
And I know as a student, like you want to enter that in your calculator. It's better if you can wait till the end. If you need to, you can enter that in the calculator now, but we have more work to do. Okay, so now we're going to divide both sides by pi.
Okay.
All right, and so at this point, it's like, where does the pi go? So the pi actually goes on the bottom. So it's 216 times 3/4 times pi equals r cubed. Right, and then we haven't talked about this at this point, but to undo a cube, you use the 1/3 power.
So why did you put 3 on the top and then 4 on the bottom?
So it's really 216/1, and then the because you can go back to the previous line, like 216/1, 3 times 216, 4 times 1, and we're going to eventually multiply it. We're going to do it all in the calculator.
Yeah.
Okay. So from here, it's just going right to the calculator, enter this in. Okay, so a couple of things here. The denominator absolutely needs parentheses around it. Okay, the numerator does not, but you can put them there if you want. So let me go to the calculator and show you how to enter this. It's the most difficult step here, really. So it's parentheses 216. Actually, let me do the numerator in parentheses also, just to show you that. 216 divided by 3. That's the numerator. Now we need the denominator, 4 times pi. And pi is a second pi under the caret. Okay, so notice I've matched my parentheses, right? I have the 1 on the outside, and then the numerator denominator, and this is all to the power of 1 divided by 3.
Yeah.
Okay, now if you don't like that, and I know a lot of students don't like that, but that is preferred. You can take the 216 and you can multiply it by the 3/4. Okay, and this is what a lot of students do. They just do it one at a time. Then they divide it by, and this is where you got to be careful. It's 4 pi, so it has to be in parentheses, because when your calculator doesn't know to divide by both 4 and pi. So you can do that, and then you take your answer and raise it to the 1/3 power, and you'll see you get the same result here in a moment. What did I do wrong?
I,
Oh, I already dealt with the 4.
oh, yeah.
So that's why I didn't get the same answer. I apologize.
You're good.
But that is the steps here.
Yeah. Okay.
All right, we're up to 35.
Yes.
Okay, and this actually would have been better to do first because now we get some like context, like why is this 1/3 power? So the analogous problem here that we should just briefly talk about is when like if I give you x squared equals 25, the way you solve this is like you take the square root of both sides. Okay, you've done that for years, but really what you're doing, this is the exact same thing, is you're raising it to the 1/2 power.
Yeah.
Okay, that's really what you're doing, is you're raising it to the 1/2 power and taking a square root. So students ask me like, well, how do I do this? Well, you undo it with the 1/3 power.
Yeah.
And on the left here, 3 times 1/3, we did a bunch of those. That becomes just x to the 1. Okay, now 125 to the 1/3 power, that's like we were doing in those first grouping of questions. You have to change 125. You have to write it as some number to some power. And you can look at that reference sheet if you need to jog your memory on that.
Yeah.
But let me know what. Actually, I mean, it does say calculator. This one really can be done by hand. I'll just give it to you because the other ones will need to do here. So 5 to the 3, 3 times 1/3 is 5, x equals 5.
I don't know if you're like drawing something right now, but you're still on the calculator. I don't know if that you meant to do
Oh, I'm
that.
sorry. I'm so sorry.
It's okay.
Happens all the time. Okay. Yeah, sorry about that. So
Okay.
I was trying to show you the analogous problem here is that you can undo a square with a 1/2 power, you undo the cube with the 1/3 power. And I was asking you what 125 is. It's 5 to the power of 3, 1/3, and then it becomes 5.
Yeah.
Okay, so for the rest of them though, we're gonna, well, maybe not all of them, but most of them we're gonna actually just go right to the calculator on
Okay.
after we write it out. But let me get this snipped in here. 37. Okay. All right. So again, like just like we've been talking about, you undo a square root or square with a square root, you undo a power of 5 with a 1/5 power. And on the left, it undoes the power of 5. Now, up until now, we've been given a lot of problems where this like 70 to the 1/5 works out, but the problem is 70 to the 1/5 does not work out. If you go to your calculator and type in 70 to the 1/5, you're going to get an awful thing. Let's see here. It's like 2.34. Okay. So you are going to put this in the calculator, but you want to wait until the last step here. So you want to undo addition by 10 by subtracting 10. So x equals 70 to the 1/5 power minus 10. And this is your answer, but your instructor wants you to go to the calculator and plug that in. So can you give that a try and let me know what you come up with for a final answer?
Yeah, let me write this.
Yes.
So plugging this into the calculator will
Yes.
actually give you an answer.
So they're both correct, but some, like if you have a calculator and it says to round, you're going to do that. But if it just says to give the answer without a calculator, what we just wrote is correct.
I got negative 7.66.
That's correct.
Okay.
And like, because the numbers don't mean anything to us. Like 70 to the 1/5 power doesn't mean anything, but you know, it just, you may want to ask your instructor like, hey, working on some problems last night. You know, are we going to have a calculator, or is it going to be a calculator, non-calculator? It's always good to know here.
Yeah.
All right, so in some ways, this question is easier, much easier than the previous one, because you just need to undo the power of 5. And how do you undo a power of 5?
You to multiply by 1/5.
1/5 power, yeah. Now, on the right, you have to do it in parentheses. Okay, that to be completely correct, you want to do that in parentheses. Minus 48 caret 1/5, like this. And go to your calculator for that.
Okay. I got -2.16.
Maybe 2.17 with rounding,
Yeah.
but yes, that's completely correct. All right, why don't you try 41 on your own?
Okay. This is just like 37.
Yeah, you're going to have to subtract first. Actually, no, you got to subtract the 36 first and then undo the power of 6.
Mm-hmm.
So just give me your final answer, rounded.
My teacher also said he told us something about adding like plus or minus, but only if the exponent was odd.
Yes, that's true. We haven't seen a problem like that yet.
Yeah.
We'll get to that. Yeah. It's a fun one. It's on standardized tests too. You see stuff like that.
I got 2.
Yes, X is 2, perfect. All right, now
Okay.
for 43 here, do you see that? Because this is the last one you think you said, right?
Yes.
So it's 1/3 X to the 4th equals 27. So you want to get rid of this 1/3 first. Now, like I was just working with a student, like, yes, you can divide by 1/3, okay? But please don't do that. Please multiply by 3 instead.
Okay.
Okay, because it undoes the 1/3, and you get X to the 4th equals 81. And go ahead and grab your calculator.
I got 3.
Okay. So let me give you an analogous problem here. Let's say it was X squared equals 9. What is the answer to this?
It'd be 3.
Is there any other answers?
No.
How about -3?
Oh yeah, because -3 times -3 is
Yes. So that's the
9.
same. That's the same problem here. There's actually 2 answers. You just alluded to it. You had great foreshadowing on that. There's actually 2 answers here. Now, how do you know? Well, it's because of this even exponent right here,
Yeah.
which we actually had in the previous problem, and I didn't even notice that. There's actually 2 answers here as well. So when you have an even exponent, and we'll get to the fractional ones, but yeah, you may have more than one answer on some of these.
Okay. Yeah. So how do you know like which equations to plug into your calculator and then which ones to just like not?
I like to get, I mean, like the ones that they tell you with, with the decimal approximation, like we did up here. I mean, those you have to. What were you thinking? Give me a little more information. I guess I'm not quite following.
Like maybe I like didn't realize, but in the last like 3 problems we've been putting it, or a couple problems we've been putting in the calculator, and then like when we first started, we were like, we can't put these in the calculator because it won't
Yeah.
get.
So I'm doing that based on the book saying that you can round your answers.
Yeah.
All of these can be done by hand, meaning you might get an answer that's nice, like we just did, like 3 and -3, or you might get it's 70 to the 1/5 power minus 10. Those are totally acceptable answers.
Yeah.
And it's just like, well, which is it? It's like, well, it's it up to your instructor. Okay, so what I would find out is like if there's going to be a calculator, non-calculator section, or what on the test, because that'll help to answer some of this for you.
Yeah.
Okay, so should we do some more problems on this page, or go back to the review? What would be best for you?
Yeah, we can do some more problems on this page.
Okay. Just look here. I guess we'll just stick with this solving stuff. So let's just look at 36. I'll try to make some more comments here as we work through some of these. So 36 is 5x cubed equals 1080. So because it's x cubed, because it's odd, that tells you that there's only one solution.
Yeah.
All right. For the other ones, there could be multiple. We'll get to that. So first thing you do is divide by 5. So grab your calculator and tell me what 1080 divided by 5 is.
It is 216.
216, good. Okay. Now, I feel like this is the kind of problem you could do by hand, even though I said grab your calculator, because the cube root of 216, you're trying to find a number that when you multiply by itself 3 times, you get 216. And that is kind of a known one on there.
Yeah.
But if you got a calculator, you just raise both sides to the 1/3 power. So x equals, and I'll let you tell me the answer after you calculate it.
6.
6, yeah. Okay, let's look at 38 next, excuse me, 38 next.
Okay.
So x minus 5 to the power of 4 equals 256. So what I notice right away is 4 is even. That means that there are either 0 or 2 solutions. Okay, so we're going to undo both sides to the 1/4 power.
Yeah.
Now this is where if you grab your calculator and when you get a 4, you're only getting half the answer because it's also -4 because of this even power.
Yeah.
Okay, now let me just show you this graphically since we got the time here. Okay, so on the left here, so we're going to graph x minus 5 to the power of 4, and then y equals 256. And you're going to see when I zoom out enough that they intersect. Okay, see how it hits twice on that graph?
Yeah.
So the even ones are going to have 2 solutions most of the time. So you just got to be on the lookout for that. It's not a great explanation, but this will be the test question that you see. So it's like x minus 5 equals 4 and x minus 5 equals -4. It's just like solving square roots. You get the 2 solutions. So you solve it by adding 5 to both sides.
Yeah. Okay.
All right, what's next here? Let's go. Why don't you try solving 40 on your own? And keep in mind there are 2 solutions to 40.
So you multiply each side by 1/4.
Not yet. You gotta get rid of that 7 out in front.
Oh, right. So
If there's a number multiplying, dividing, adding, subtracting, you get rid of that first, unless it's in parentheses.
so divide by 7.
Yes, divide both sides by 7.
So then x to the 4th equals 8.
Yes.
And then we do 1/4.
Yes. But because it's even, there's 2
Two
solutions.
solutions, yeah.
So that's what your instructor is saying, plus or minus.
Okay. So it's gonna be x equals 1.7
Plus or minus?
plus or minus 1.7.
Yeah. Yes, perfect. All right, let's look at 42 now. X cubed plus 40 equals 25. And like the last problem, you have to undo multiplication, division, addition, subtraction first before you do anything else.
So you subtract 40.
Yeah.
So it'd be -15.
Yes, and the odd ones always have a solution. Odd powers always have a solution.
Okay.
So you actually want those on the test because there's no weird, exceptions.
So it'd be -2.5.
Sounds reasonable. Okay. Why don't you try 44 on your own here?
Okay. So you multiply both sides by 6.
Yes.
So x cubed equals 216.
Yep.
But it's positive. Or negative, it's negative.
Yeah, it's gonna be negative. Yep.
And then it's x equals -6. But there's 2 solutions.
Only when it's an even power. You have an odd power
right,
here.
right,
Odd
right.
powers. I'm glad we got to that here at the end because that's an important distinction. Odd powers have 1 solution. Even powers have 0 or 2 solutions.
Yeah.
And we'll see that here. And
I just need to remember which ones to do.
yes. Yes. So let's go back here. Unless you want to stop, we can do one more problem if you'd like. We can stop here.
Yeah, we can do one more problem.
All right, so let's go back to the look at 18. So 18 is 16 to the -7 over 4 power. Now 16 can be written as a number of things. It's either 4 squared or it's 2 to the 4th. I mentioned this earlier. It's always good to match the one that has the same bottom. So let's rewrite 16 as 2 to the power of 4. And the reason you do that is because when you multiply the exponents, you want the bottom to cancel. You want the fraction to go away. Nothing worse than having a fraction and an exponent. So that becomes -7.
Yeah.
So this is 2 to the -7 power. So what that means, and we did this earlier, is you have to move it to the bottom.
Yeah.
All right, so it becomes 1 over 2 to the 7th. And then what I try to remember like 2 to the 6th is 64. And then so 2 to the 7th is doubling 64 or 128. All right, well, that is it for us, Isabel, for tonight. Thanks for letting me help you.
Thank you so
Gonna
much.
jump off here. Yeah, I hope you have a great rest of your week and I'll see you next time.
Thank you, you too.
Okay, bye now.